Welcome to the M2CQ design video. First, we'll give you a rundown of our design description. Design can be broken up into four main sections: power distribution, temperature monitoring, motor and flight control, and the transmitter receiver pair. The major components include battery power distribution board, a battery elimination circuit as part of the Hobby King 40 amp ESC, two Arduino Uno microcontrollers, a TM36 temperature sensor IC, SparkFun passive buzzers, KK 2.1.5 flight controller, a DJI 920 kV motor with 9.5 inch props, and a Turnigy 9X 9-channel transmitter receiver pair. So inside of here we have our main power distribution. So for the battery power going to the ESCs, since they're branching off into four different spots, there's one central board that's connecting the battery power inside of here, and then that's going to route the power to the four ESCs. Using 11.1 volt battery. It's a LiPo battery, so it has 3 cells, each one 3.7 volts. And then for everything running off 5 volts, we have the ESCs using their SBEC, which is pretty much a power supply, switching power supply, and it's maintaining the voltage at 5 volts for the flight control.
The ESCs that are being used for this quadcopter are 40 amp ESCs, which were chosen because there was an expected current of about 15 or 16 amps through the ESCs, so we have a wide margin for preventing any overheating problems with the ESCs. And then the motors that are being used are 920 kV motors, which just means that for every volt you get 920 rotations out of the motor. So right now we're looking at the temperature sensing module. This board has the red wires are for the power, the black is a ground, and then these brown wires over here and here are for the signals. These on the left are the signals to the ADC, and this one over here on the right is the signal to the speaker, which is right here on the quadcopter.
So right now we're connected with our Arduino to a computer, and that way we can read the temperature data coming on the console. So if we stop, we can see that without anything running, our temperature sensors are reading ambient temperature in the room. So that's an example of the alarm condition. Anytime the component temperature is going to go over 170 degrees, we're going to send out an alarm to the user so we know it's time to shut it down.
So now we're going to take a look at our flight controller, which we chose to use the KK 2.1.5. And over here on this right side, we have the connections for the motors, which has options to put up to 8 motors for an octocopter, which was one of the original design objectives, to be able to be flexible with what kind of quadcopter. And for the motor layout, we've got them in a plus formation, so on the top and bottom we have clockwise motors, and on the left and the right we have counterclockwise motors.
Alright, now we're going to go through our flight controller menu settings. This adjustments make sure that you're able to adjust the sensitivity of the transmitter to the, skill level that you have, as well as set up the self-leveling features and a couple other cool things. So starting at the very bottom would be the factory reset and debug, which right now we have everything set for what we need, so we're going to leave those alone. Here, the load motor layout. You can adjust your layout to different multi-copter formations. Like we said previously, right now we're using the plus mode for this quadcopter. So we're going to load that up. And this here shows you the different formations for each one of the motors. So right here we have motor 1, clockwise, motor 2, counterclockwise, 3, 4, so forth. and then it just shows you that the rest of the motors aren't connected. Next up, we have the show motor layout, which is just a duplicate of the previous screen, showing you where everything's set up, the location for all the different motors. And then we have the calibration for the accelerometer. So laying this out on a flat surface, click and continue, it's going to calibrate everything to sense where that ideal level location is. So once your settings have been calibrated, it's going to give you the X, Y, and Z location for where the quadcopter is going to try to self-level. Next, we have a sensor test. This is just a display saying that all our sensors are okay, which is a good sign. And then moving right along, we have a camera stabilization, something that we don't have located on this quad, but provides the option if that's what you want to use. Here are self-level settings, controls the power and gain limits for the controller. If the controller is set too high, you're going to get jitters and oscillations in the controller, which is going to cause very unstable flight. And then if the setting is set too low, it's going to be very slow to response, and you're still not going to get the flight that you want.
Oi!
Next up, we have stick scaling. This adjusts the sensitivity to the transmitter, so how sensitive you want it to be to your response when you're adjusting different parameters. For more experienced flyers, it's okay to have more sensitivity, but for beginners, you want to set this value kind of low. Next, we have a receiver test. So ideally, with all the receivers in their default location, you're going to have all zeros for these values. If it's offset for any reason, that means that your receiver is going to be telling your controller to move without you even giving any inputs. So this is adjusted using the trim controls on the receiver. So right now you can see we're at -7 for elevator in the default position. So using the trim settings, we'll just go back to 0 it out, and that's where we want to be. And finally, we just have the editor to adjust the different gains and limits for each of your different throttle controls, and you can scroll through those. So that, for the most part, is how you set up your flight controller. So here we have our transmitter and receiver pair. We're using the Turnigy 9X 9-channel receiver, and the amount of channels just lets you control various things. So with the additional channels we have here, we could have went for camera stabilization and things like that additionally, but we kept it with the basic layout. So mainly we're controlling the throttle, the speed of the motors, the pitch and roll, and pretty much just positioning of how we're moving directionally. So in order to arm our flight controller, we have to have the minimum throttle position, so all the way down here, and then we turn our elevators to the right. So now our flight controller is going to display that we're armed. And then to disarm, we go back to that minimum throttle position and just position the elevator to the left. And now we're back in safe mode. This is also how you enable the self-leveling settings. So by holding this stick to the right during arming, you set up self-leveling, and turning this to the left, you turn it off.